Now, we will have 1, 2, 3, 4 talks, contributions, and after that we will have a panel discussion about the issues which are emerging during these talks. As I mentioned on the Slido, you can put up questions, and just yesterday on the Nature briefing, there was an article about how you allocate funding for projects, and the big issue is that I think it was New Zealand, where they allocated on a lottery basis, of course not taking all the projects, but selecting some and then have a lottery. So I took this example, and I would like to put up that question: that would you support to use the combination of a peer review and a lottery method to award research grants? And I'm very interested that what the audience think about it. So if you log in to the Slido, and then you can have your opinion on that, and at the end we will see what the opinion of this audience on this issue, which is about how you select competitive funding the project. Now, our next speaker is His Excellency Blade Nzimande, as the Minister of Higher Education, Science and Technology of South Africa. He was Minister of Transport previously. He held different positions. His academic qualification, he holds a doctorate in philosophy, specializing in sociology, and this PhD is from the University of Natal. Your Excellency, please, the floor is yours.
Thank you very much, Program Director. Thank you for this opportunity to share with you what I hope is both an African and a global perspective at the same time. On this important question of ethical consideration to be taken into account in research. In the first instance, let me thank Dr. Cordova for her keynote input, which I think has appropriately set a context for this discussion. Indeed, the National Science Foundation is also an important partner for South Africa's main national science funding agency, the National Research Foundation. Together, the NSF and our National Research Foundation work together with forums such as the Global Research Council to advance, amongst other things, a greater consideration of ethics in competitive research funding. I'm also delighted to share the stage with Professor Hassan, who has been one of the champions for the advancement of science, African science, over the past decades. Dr. Hamaguchi is another old friend of South Africa, who is with the Japan Science and Technology Agency. It's also fitting that we are joined by Dr. Annette, who represents the next generation of young scientists. In my contribution this afternoon, the 10 minutes or so that I've been given, I would just like to start by raising 3 key points, which I think they hopefully should be part of this discussion. Firstly, I would like to urge that the determination of which ethical considerations should govern research funding and the scientific enterprise should be done in an inclusive manner, both with regard to geography and interest groups involved. In other words, it matters who determines what is ethical, and that cannot be unilateral, which means that there must be debates, there must be engagements to emerge with common understanding of ethical considerations guiding research. Secondly, I propose that promoting research integrity and respect for ethical considerations should be an integral part of the research promotion effort. It is indeed a precondition, in my view, for achieving excellence in science and promoting science which makes a qualitative difference in society. And thirdly, governments and national research funding agencies have an imperative and responsibility to advance research integrity and greater respect for ethical considerations in science. Important efforts are being made, but much more needs to be done through, for example, regular independent assessment of policies and institutions. With regards to my first point, the agenda setting for ethics in science must be truly inclusive. It cannot be determined by funders alone and must be sensitive to the rights of especially vulnerable groups. It's important that we debate this all the time. The effect and the impact of funders on research. Sometimes, well, I would argue that, strictly speaking, there is no funder who does not have an interest in what research should actually be doing. But often, sometimes it's important that that interest is declared and it's open and it's known, rather than to pretend as if there is no interest when in fact there is an interest. This is also important, for example, with regard to indigenous knowledge systems. The international ethics in science debate must give the opportunity for all voices to be heard, especially in the current global situation that the voices of the South in platforms such as these must also be heard. Science can indeed help build a basis for a knowledge-based society and a healthy economy, but also can cause harm. That is why for us also the issue of ethics must be located within the context on always seeking to answer the question, science for what? As I said last night, for South Africa, science should be used to pursue peace, to pursue global understanding, to pursue equality and justice. And that is very important in shaping the very ethics of science. On the second point that I had made, for science to make impact in our society, we want especially to focus on the importance of the achievement of sustainable development goals as an important framework within which also to guide us in ethical research. It's one of the objectives, for instance, of our own policies in South Africa to ensure that our efforts are guided by achieving a better society and a more inclusive society. South Africa, like all nations, must also respond to the challenges and opportunities of the so-called fourth industrial revolution, which increasingly, as everybody is saying, is blurring the lines between the physical and the digital spheres, and this raises very important legal, ethical, and socio-economic consequences. For instance, today we are talking increasingly of face recognition technologies, but what do such technologies also bring about as an unintended consequence, which could also violate individuals' privacy? Our own policy paper in South Africa sets an objective of instilling a responsible research and innovation approach, which then also brings me to the point of what should be done by governments and funders. I would like very quickly to end by proposing 6 principles that should guide the ethical funding of science, drawing on the framework of both the European Union and other bodies around the research effort. Firstly, the engagement of all societal actors through the process of framing societal challenges and developing science funding programs which will deliver joint solutions is very important. Secondly, addressing racial and gender transformation to unlock the full potential of global scientific talent must be a priority for all. Science and innovation is located in all of society, and therefore it's important that no particular groupings are discriminated against or excluded. Thirdly, improving the educational and skills profile of all citizens, including the most vulnerable, must underpin our efforts to achieve the Sustainable Development Goals. The fourth principle, open access to science, technology, and innovation, is important as part of democratization of science. Although I must say that there is quite a lot of resistance, especially within academics circles, on the issue of open science. How open is science? Can you have open science in the context of unequal global or regional relations, for instance? Is open science not merely serving the interests of those who are powerful and having the capacity to process the data that is actually being collected through open science? I think these are some of the discussions that we must frankly and honestly open up. Also, fifthly, the fifth point, we need to maintain a high level of ethics in terms of relevance and acceptability of science to society, including the issue of environmental sustainability. And we must not shy away from raising some of the threats to the scientific pursuit. Like, for instance, the existence of climate change denialism within very powerful sectors of the globe and the world is something that we should, as part of our scientific pursuit and as part of ethical considerations, be something that we raise rather than to shy away from. The sixth principle is that we do need, on an ongoing basis, to develop the required governance frameworks to drive the global responsible research and innovation agenda, which must be advanced in multilateral forums as well. Let me conclude by saying I hope these principles will stimulate further discussion, because in the words of the first African to receive a Nobel Peace Prize, Chief Albert Lutuli from South Africa said, and I quote, "Scientific inventions at all conceivable levels should enrich human life," unquote. And this objective still is and remains the primary goal and responsibility of science funding, as well as the ethical basis for scientific pursuit. Thank you very much.
Thank you very much, Minister Blaise Manne. Our next speaker is Professor Mohammed Hassan, and I happen to know that today is Professor Hassan's birthday. So, Professor Hassan, happy birthday to you. I won't sing a song here, but happy birthday. No, I won't disclose that. Mohamed Hassan is president of the World Academy of Sciences, president of the Sudanese National Academy of Sciences, and chairman of the Governing Council of the United Nations Technological Bank for the least developed countries. After obtaining his PhD in mathematics from the University of Oxford, he returned to Sudan as a lecturer in the University of Khartoum, and later became professor and dean of the School of Mathematical Science. He holds many other responsibilities. Again, I will not list them. So I just ask that Professor Hassan, please come up here and deliver your talk.
Oh, well, thank you very much, Professor Balankish, for this introduction and the good wishes. And I would like to thank also the president of the Hungarian Academy of Sciences, Professor Lovas, and his colleagues for inviting me to give this talk. You have certainly picked the right day to do it. So what I really would like to highlight here, if I can have the, how do you operate this? This is your presentation. Yeah. Which one is yours? This one? Yeah. Okay. Okay. So what I will talk about, I would really like to tell you how the global, it's not working. This is the title of my talk, The Global Inequalities. I think this is not controlled, it moves, no? All right. I just want to keep the, okay. The global, it goes automatically. I don't think it likes me. It wants me to finish my talk very quickly. So yeah, okay. You cannot stop it. All right. Well, in any case, I want to talk about the inequalities in financing science, technology, and innovation. And I would like to talk about two issues. One is, one is the global inequalities in the science and technology and innovation landscape, and linked to that is the global inequalities in financing science, technology, and innovation. So let me just begin by saying that the fulfillment of the Sustainable Development Goal is certainly a global moral obligation for all countries. And this because the global sustainability really requires that all nations achieve all the Sustainable Development Goals. No country, as was mentioned last night, no country should really be left behind. And at the same time, we have to emphasize once again and more that it's only through science, technology, and innovation that these Sustainable Development Goals can be achieved. So, oops. So let me just talk very briefly about the changing landscape of global science. And this is the sort of statistics that we have collected through the years. Between the period 1981 to 1994, all the developing countries, including China, India, and Brazil, contributed only 15% of the total peer-reviewed publications in the world in the area of science and engineering and medicine. In the year 2000, between the year 2003 and 2007, on average, that 15% jumped to 25% or 26%. So that's a huge jump. But a substantial jump occurred when you compare all this with the year 2016, where the developing countries contributed 44%. And that's really a huge jump. What is so disturbing in this is that Africa did not move that much. from 1.4% to 2%. So there is still a lot of problem concerning Africa. And this is the picture in 2016. And by the way, this is the data that Professor Cordova mentioned, the book, the Science and Engineering Indicators 2018 of the National Science Foundation. So these are not UNESCO statistics. This is the National Science Foundation statistics. So in the year 2016, the world published 2.3 million articles, 27% of them from the European Union. China contributed 19%, which is 1% higher than the United States. And this is the first time that we see China publishing, or Chinese scientists publishing more papers, peer-reviewed papers, than the United States. Whereas at the same time, we find Africa 2%, and even more disturbing is the least developed countries contributing just 0.4%. And this is a population of over 1 billion people. So this is where I see the disparities and the problems related to that. And this is how you can see it in terms of countries. So you can see there are 12 countries. The top 12 countries produce over 70% of the publications. And the top 22 countries produce about 85%. So 15% for the rest of the world. So these are the disparities, ladies and gentlemen, that are so disturbing, and sustainability cannot really occur as indicated in the Sustainable Development Goals unless this is rectified. So let me now move on to the global inequalities in financing science, technology, and innovation, which is really a reflection of what we saw for the disparities. Again, this is also the National Science Foundation statistics. The global R&D expenditure in the year 2015 amounted to $1.9 trillion. The United States, the largest contributor to that, 26%, China 21%, EU 20%. So the total for these three regions is 67%. And this is how it is indicated by the National Science Foundation. So you see, the regions with the arrows, those ones. These are where most of the contribution has been made, Europe and East and Southeast Asia. And Africa, for example, just contributed about 1% of the total R&D expenditure. And Latin America also about 2.6%. So the disparities, again, are reflected in the ways research and development is supported throughout the world. Now, this is a very, very interesting article written by The Economist at the end of last year. And most of this data is taken out of the National Science Foundation report. And so you can see the way China has increased its contribution in terms of the number of articles published, starting from low number and exponentially growing. At the same time, just try to this is the way that I try to convince some of our governments that this increase in publications, which reflect the strength of science, really corresponds to the budget allocation for science and technology. So both of them are exponential growth. So if you increase the budget for science and technology, this is what you get in the increase of the budget. So this is, I didn't want that, not yet. At the same time, if you look at the military expenditure, you see China is really slowly going up, whereas the others are really still far away, Europe and the United States. And now this is the military expenditure database. This is the Stockholm International Peace Research Institute, which lists the ranking of countries by the amount of money they spend on the military. Of course, the United States and China are at the top, and the others are really far behind. But what is interesting is you see there are 5 developing countries among the 15. Now, this is even more disturbing. If you look at the percentage on the military as a percent of the GDP, among, oh, sorry. So among the 15 countries that are ranked number 1 to 15 in terms of their expenditure as a percentage of GDP, there are only 3 developed countries, and all the others are developing countries. And this is why we have such low productivity into developing countries, because most of the money is really not spent in the right way. And this is where I think the problem lies. Even more disturbing is this table there. Oops. Now, this table shows the government spending, the amount of money available to the government to pay for health, for agriculture, for education, for everything. And this is the first time I see my country, Sudan, being the top of the list. I've never seen it like that before, but it is for the wrong reason. You know, in the country, at least until last year, over 30% of the budget available to the government to spend on various sectors is spent on the army and the secret police. And then again, you can see that all these countries are developing countries. These are the 15, except 3 of them. So this is really a very disturbing picture. And I think unless we change this, I think we'll have very difficult time in addressing or achieving the SDGs. I'm happy to say that in Sudan, the picture is improving. We now have a new government. The dictatorship that ruled the country for 30 years is now gone. And we have a new system now, and this is one thing they are looking at right now. You know, we have to change this. Okay, this is another issue which is important when it comes to research and development support. And this is I would really argue that this is an area of research that I think should be taken up by the international community. And the question is there a bias against women in research funding? Well, you can see from this so-called scissor phenomena that when students enter the university, the girls in number are more than boys. And we have this even in our region, in the Arab region. Not only in number, but also in quality. Oops. What's happening? Just about the last, no, before that one, yeah. Okay, yeah, this one, yeah. But it doesn't reflect there. Okay, but as we move on, at the level of graduation, they are almost equal, but as you move on along the ladder for the master's degree, PhD, and research, the gap starts to widen, and widen substantially. But the recent thing is the statistics that has been generated for innovators, for those scientists who have got patents, invention and innovation. Then the gap becomes very wide. And that is why I raise this question. I mean, there are so many factors, no doubt about that. I mean, women have lots of problems and so on. But is it really because of the disparity in getting funding for research? Are they biased against when there are allocations for research by organizations locally or regionally or globally? It's a question that has to be addressed, no doubt about that. And I think when you talk about gender issues and gender biases and so on, this is an issue I think that has to be addressed. So, So the point, I have 4 points. No, it doesn't stop. Well, I really have 4 points that maybe one should look at when it comes to recommendations. The first one is if you really want to address these global inequalities, the most important decision or recommendation one can make is to increase the government expenditure and allocation to research and development in all countries across the globe, especially in the developing countries and the least developed countries. And the level that has been indicated many, many times is that it should be at least 1%. At the moment, no African country had reached this level of 1%, including even South Africa. South Africa is close to it, but not yet. So that, I think, is a real issue. The second is the funding provided to the poor countries through the ODA. And these funds, I think it needs to be re-examined in view of the Sustainable Development Goals and the encouragement of countries to implement the Sustainable Development Goals. I think more allocation of ODA funding should be given to quality education, to research, to addressing the issues related, the challenges related to the SDGs. We have to ensure that if we want to address the issue of fairness in the distribution of research funds, we have to ensure that the expert panels that review and evaluate the research projects and awarding the grants, that should at least be gender balanced. At the moment, we don't have that. I mean, in the organizations that I work with, 80% normally are men. And I don't think that is proper, and that might be part of the problem why women are not funded sufficiently enough. And then finally, I think the whole world now have to address how to help low-income countries in the area of research, innovation, and entrepreneurship capacities, especially the least developed countries. And this is the only way. If they do not have sufficient capacities in those areas, in innovation, in research, and entrepreneurship, there will be no way for them to achieve the Sustainable Development Goals. So these are the 4 recommendations I would like to make, and thank you very much. Okay?
Thank you very much, Professor Hassan. And our next speaker is Professor Muchimari Hamaguchi, President of the Japan Science and Technology Agency. He is president was previously president of Nagoya University, and his scholarly interest in pathological medical chemistry. He currently serves as a chairperson of Council for Science and Technology, Ministry of Education, Culture, Sport, Science and Technology in Japan. So Professor Hamaguchi, please.
Which one is Hamaguchi is the name? Yeah. Thank you very much for kind introduction. Distinguished guests, ladies and gentlemen, it's really honor and pleasure to be here. And I'll talk about funding for well-being. Oh, no, it's, I don't know. Yeah. Okay. As you may agree, we are now living in an era of instability, where natural and man-made disasters can strike without warning and tear lives separate. Science can do more than simply generate research results. I think we must focus on widespread human well-being as our ultimate goals. We must ensure that quality of life across the globe is protected and enhanced using science to shield the vulnerable from life-altering disasters. The Sustainable Development Goals, SDGs, already provide clear frameworks through which we can achieve responsible, inclusive growth. Science and technology are a key tool to make meaningful progress by 2030. But this will require firm commitment by a wide range of stakeholders, including citizens. Today, I would like to talk about our ethical approach at JST as a science and technology funding agency, which we apply in our variety of funding programs that target human well-being and prosperity. I start by asking all of you. This is a question Chairman requested me. What is well-being? What do you think? And do you believe science can contribute to it or not? Yes or no? Can you trust science? Okay. Why not? Because I will explain later. We lost public trust in our history, recent history. Anyway, we and the science community have 3 channels through which we can contribute to well-being. Let me one by one explain what is I'm thinking about it. And I would like to emphasize ethics is not simply a technical issue, but it is an issue of vision. We need vision, I think so. Why? Let me start. We have 3 types of research. One is basic research, as you know. This field, we drive it by the curiosity-driven curiosity-driven manner. And in this field, program, we must keep transparency and accountability in its to pursue it. And another one is mission-oriented science. We have mission-oriented science here. Our response is in this. Sometimes we have to take high risk to make innovation in a society, but we have to avoid fatal risk. It's really difficult. And in our case, both basic research and this mission-oriented science, our agency send our staff to the scientist side, and we communicate in monthly pace to check whether the research is in a sound way, whether they manage their research in a good condition. We communicate all through the research period to make the research we can keep accountable. This is the way we usually operate. And difference from the basic research, mission-oriented research, we usually form a group of teams. A typical one is the COI, Center of Innovation. We selected 18 universities, and during 5 years of the research, we already have more than 300 companies join this center, and they can collaborate with academic people. And we call it under one roof. Under one roof means we offer a building where academic people can share the space with industry people, and they can communicate in a daily basis. And this communication is, again, I think, a very important part of ethics in our society. That makes the research sound and transparent. And third one, I would like to introduce as a disaster response. When disaster strikes us, we have scientific response generally. But I remember almost 80 years ago, we had a huge devastating earthquake in Tohoku area in 2011. And at the time, we lost almost completely public trust to science. Why? We couldn't predict. We couldn't mitigate the disaster. I know, scientists know the limitation and incompleteness of science, but we couldn't explain to citizens the defect of science we have right now in Japan. And after all, the earthquake killed more than 20,000 people. Most of the people passed away by the so-called tsunami. You know, tsunami is a wave, but not a simple wave. It's a huge wave, higher than this ceiling. Sometimes it reaches fourth floor of the building. Some of the victims escaped to the building top ceiling, but they couldn't survive because the wave was so strong and comes so fast. And even they survived, they got so-called tsunami lung. It's an infection, severe infection that kills people. And at present, around 3,000 people we couldn't find yet. We miss them. This is a result. And these kind of disaster not only kill the family, friend, people around your home, but also it destroy your home, hometown, culture, job, and even your future. For example, we had in the Fukushima area, we have a nuclear power explosion. And many people were devastated from these areas, but most of people, after all, wanted to stay at their hometown, although they worry about the irradiation. So we invented a small Geiger counter and offered it to high school students and let them measure their irradiation during their daily life. And what we found is, irradiation they had is almost normal. Sometimes it's smaller than other cities' high school board. That means they can stay at their hometown and spend their life as usual before the tsunami came. This kind of small experiment, but its effect is very big, I would say, for their life. We had more than 600 projects like this. Another example for it is oyster cultivation. Seashore area, fishermen cultivate oyster, very nice oyster around the area. But this was destroyed because the seashore was desertification by the tsunami. But one guy invented a small experiment, and that recovered the oyster after 2 years. Its cost is small, but it can support people. Anyway, disaster response is nowadays another important issue for scientific research, and it can clearly escalate issue for us. Also, it doesn't matter man-made or natural disaster. Many people suffering from these things. Anyway, and to make it possible, we need international collaboration. We have many programs, so-called SATREP, SciCoop, AGECOR, Concert Japan, anyway. And to make it more good and successful, we need young, talented people who can join us. And this is another conclusion today. Thank you very much.
Thank you very much. The next talk is by Stephanie Annette. She's an honorary lecturer and a postdoctoral research fellow, School of Pharmacy and Biomolecular Science, Royal College of Surgeons in Ireland. And Stephanie got her PhD from Queen's University and completed it in experimental therapeutics in 2017 with a focus of developing drugs and target cancer stem cells. So, Steph, please.
Thank you for that introduction. And thank you for the organisers for inviting me to speak today on this important topic. I hope I do it justice. It's such a complex topic for only 10 minutes. And I will try and slow down my Belfast accent, as I know it's extremely hard to understand. So let me know if I'm going too fast. So today I want to talk about new drugs, where they come from and why they cost so much. So let's take ourselves back to Canada in 1922, when insulin was first described. And it is undoubtedly one of the greatest contributions to medical science, saving millions of lives worldwide and being safe and effective. And one of the discoverers of insulin, Frederick Banting, famously declared that insulin does not belong to me, it belongs to the world, and he sold the patent for $1 US. And as we fast forward to 2019, we have since broken the record on the world's most expensive drug at a whopping $2.1 million US for gene therapy to treat orphan disease, spinal muscular atrophy. And at this price, you would like to think that it's both safe and effective, but unfortunately, post-approval, there's been data that's came out to show that some of it has been falsified, and there was some hidden safety data issues. And so the high drug prices charged by pharmaceutical companies have an impact globally, whether you're in the developed world or the developing world. And in the Western world, we've become accustomed in recent years to public protests and public petitions at access to drugs that are being rationed, such as new antivirals for hepatitis, or the latest this year, at access to Orkambi for cystic fibrosis patients. But also in the developing world, some of the drugs that have revolutionised healthcare in the Western world are still not available. So trastuzumab, or Herceptin, revolutionised treatment for HER2-positive breast cancer and is a World Health Organization essential medicine, but despite being developed decades ago, is still unavailable to the majority of the developed world. So why are medicines so expensive? And it's simply because pharmaceutical companies can charge high prices because they're patented. And these high prices are important for maximising profits and keeping shareholders happy with the value of stocks and shares high. And drug companies have a monopoly on a drug for approximately 20 years, and they can charge whatever price they want. And this is all underpinned by World Trade Organization agreement and the TRIPS agreement. And so the justification and the familiar narrative that we've all heard for the high drug prices is that the companies need to invest in R&D to recoup their costs and to improve future R&D developments. And indeed, the industry-funded Traff Centre for Drug Development does estimate that it costs $2.7 billion US to bring a new drug to the market. But the problem with this report is that its methods are opaque and there's a complete lack of transparency, and this has been criticised by a number of high-profile people and a number of agencies. And two oncologists published in JAMA a couple of years ago decided to do their own study to try and find out the cost of a new drug, and they estimated that it costs about $6.4 million to bring a new cancer drug to market. So why is there such differences in prices? And one thing you have to realise is that drug costs don't equal research costs. And there's a couple of many reasons behind this. And in recent years, there's been a shift from in-house drug development by the pharmaceutical companies to acquisitions of small startups where the basic science has been done. And pharmaceutical companies, particularly the big ones, spend eye-watering amounts of money on sales and marketing, and you can particularly see this in the US with the amount of drug advertising that is thankfully more regulated in Europe. And most of them are thought to spend more on marketing the drug than they actually spent on developing it. And my third point is what I want the take-home for today to be about, and that's thought to be up to 1/3 of the R&D costs are actually paid for by public money. So it's very difficult to get a figure on how much is actually publicly funded because of lack of transparency. But this paper published in BMC Medicine, taking data from the UK, they did try to quantify it, and they estimated up to 2012 that approximately 40% of R&D costs for a new drug is paid for by either taxpayers or by charitable donations, compared to 55%. And research done by the Mayo Clinic has estimated that it's up to 85% of new drug R&D is funded by public sources. So what is publicly funded innovation? So universities and research institutes worldwide are subsidised by the public sector and by charities to carry out vital scientific research. But the problem is that publicly funded research does not guarantee access to patients and does not guarantee that medicine will be available at an affordable price. And taxpayers and patients worldwide are being denied medicines that they need, despite the pivotal role that public sector funding has played in the discovery of new medicines. So we'll just take albuterone as an example. So it's a hormone therapy that was developed for advanced prostate cancer. And it was originally discovered in the Institute of Cancer Research, which is a publicly funded research institute associated with the University of London. And in 1992, the patent was first filed. Then its development was funded by both publicly funded groups like the Medical Research Council or charities such as Cancer Research UK. And they paid for public funding right up to phase 3 clinical trials. And it's hard to know, because of lack of transparency, how much was actually privately funded. And the British Technology Group then took charge in commercialising the drug, and they licensed it to Cougar Biotech, which was then subsequently bought by Johnson & Johnson in 2009 for $600 million. And when it first got approved, the UK rejected it on the grounds of cost effectiveness. It took 5 years of negotiations, and they were able to get the price down to £98 per day, which is a bargain compared to the US cost. And within 2 years of post-approval, the NHS, or the National Health Service, spent £1.27 million on this drug, despite UK public money playing a pivotal role in its development. And globally, it should be on the World Health Organization's essential medicines. In 2019, it was recommended, but it was thought that it was rejected on the grounds of costs. And prostate cancer disproportionately affects sub-Saharan Africa. And the patent got extended by combining the drug with a steroid, and generic manufacture is blocked in most of the world until 2027. And the generic price per day is estimated to be only £3. So if we look at the income then that it's generated, so Janssen, which is part of Johnson & Johnson, even though they came in at the late stage to buy it, the sales at the end of 2016 had reached £7.5 billion. And only the Institute of Cancer, the original ones that discovered it, only received about 2% of the sales income. So effectively, governments are paying twice for medicines, first through R&D, and then by the high prices that drugs are then being charged to governments, despite the reliance on public funding. And these high drug prices distort research priorities. They distort them to the areas of best commercial gain, emphasising financial gains and not health gains. And we need to take steps to ensure that public funding leads to the development of life-saving medicines that are accessible for all in every country throughout the world. And there has been plenty of reports on this topic. The biggest one would be the one by the UN on their access to medicines. And they have produced recommendations to try and help this ethical issue. And first of all, they want to attach public interest conditions to funding, and that the research funding bodies should be demanding this and they should be enforcing this. And there should be transparency. We should know how much of new drugs R&D came from public funding and how much was paid for privately. And there should be governance and there should be accountability, and intellectual property coming from public funding should be licensed in a way that protects access. And then their last recommendation was to de-link the price of R&D costs from development, so try and break the monopoly system that does not work for public health. And there has been a not-for-profit, famous not-for-profit called Drugs for Neglected Diseases Initiative, which has done this very successfully. And they write in affordable access to the end product from the very start. And that to date, they've brought 7 new treatments to market. And the first new malaria treatment that they developed in a partnership with pharma company launched at a price of only $1 per adult treatment. And it's estimated that in the first 4 years that the drug initiative has saved the lives of nearly 1 million people, and that will be a lot more today. But the problem is that countries have had different responses to these recommendations, with most of the global south supportive of, but unfortunately the US, the UK, Germany and Japan, those countries that spend the most on health R&D, were critical of the report. And we have to consider corporate influence over these Western governments. And although collaboration between academia and industry is necessary and fruitful, this bias towards corporate interest is overriding public health interest and is creating these problems that we see today on access and price. And in the future, I hope that tax-funded and charity donations should be used for the benefit of patients, and that governance should reflect that priority, and that big pharma should not be making these large profits from drugs they did not invent. And I think that we're getting into the serious situation where people run marathons, they are so passionate about raising money for Alzheimer's research or for cancer research, and there's going to be a day where they're realising that we're undermining their trust and there's going to be resentment. And also, as a young scientist in that area, I hope that there's more infrastructure to be able to empower scientists and clinicians to work together to take discoveries from the bench into the clinic without always having to involve big pharma and having more control over the diseases and the drugs that we invent. So thank you for listening, and I look forward to any discussions.
Thank you very much indeed, and thank you for keeping the time. So may I ask the panelists to come up to the podium? We will have 30 minutes of discussion. I prepared some questions, so please come. I will not put them all because that will take us very far, and we run out of time. The only question I would like to put up first is about competitive research funding. And what do you think, what are the deciding factors when competitive funding is made? Whether it's the previous achievement of the scientist or the thoroughly assessed possible value of the proposed research, and how to balance these decision making. So this would be my question to the panel, and later on we will have the possibility to have some questions from the audience. So who wants to take the first?
Okay, good. So the NSF just has two criteria. One is intellectual merit and what is broader impact. And we've had those two criteria for a very long time. And all the reviewers are kind of trained in what to look for on those two criteria. So I think they balance it very well, and we occasionally have discussions over what broader impact means. As you can imagine, that changes with society.
I think as an early career researcher, we also have to remember the mental health effects that the competitive funding environment has on us. And I also think that we have to consider how it drives research in areas that not necessarily are priorities. They're priorities that's decided by the funding agency and not what we think as researchers. And I'm sure we all write grants to match what we think that they want to hear, and I'm not sure that's how we should do science.
Oh, okay. No, just very briefly. I think that this point has actually come across quite strongly in almost all the presentations about, because at the heart of it, maybe it's what I was trying to refer to, that we should be working behind science for equality, and that should also be informing, hopefully, the kinds of competitive funding that we are talking about. I must say that what has come out in the two presentations, the one on drugs and the ones on countries' expenditure, actually underlines the point, that where we should be focusing our attention as the science community. Of course, it will not just be scientists alone. It's scientists and governments and publics that actually need to be shaping how we actually get. Because funding is not just being competitive in abstract, it must also be just and also be aiming to redress the kinds of inequalities that we have.
Yeah, I really completely agree with the Minister. First, competitive funding, I think, is very important. It's a must, because you really want to support the best projects, the best proposals. You want to pick them to ensure that they are fairly selected, and I made certain observations concerning that. You have to minimize the risk in funding research, but at the same time, you really have to be bold. You have to support bold ideas, because it's only through bold ideas that you get substantial impact and benefit. So on one hand, you really have to raise the bar as far as risk is concerned, but make sure that that most likely is going to generate support to projects that are really going to have substantial impact. The question I would really like to address, maybe to my panelists here, if I may, is where do you really draw the line? And whether you really have in place regulations and rules that will not only minimize the risk, but that will ensure that you observe the failure right at the beginning and not let it just continue until the money is gone. So that is, I think, in my view, very critical. And it's those organizations that really put in place very good risk management that really succeed in raising the bar for risk.
I think from the side of the funding agency, transparency and accountability is a very important issue. It's a baseline of the research. And for the sound competitiveness, I think we need respect and trust of the based on mutual communication among the researchers. So In our case, we usually form a group or researcher focusing on one issues and let them discuss in a monthly basis or once a year, or half a year to communicate. Let them communicate deeply. Then deep communication brings respect and understand of difference and similarity of each other. This is a very important point, part of our project, trust and respect.
Thank you. I would like to put up a little provocative question. Sometimes I feel that the society has large and sometimes unrealistic expectations from scientific research, partly because when we are arguing for more funding, we tend to overpromise. What do you think? How can the most prestigious and responsible scientists and institutions handle that the public is properly informed what science can deliver and what research can deliver and what research cannot deliver? Is that a problem, you think, or is it not a problem?
All the microphones are down.
Yeah. Okay. Can you pass one of the microphones? So I will be still in control.
I don't think it's a problem. I think it just depends on where you are on the planet, whether it's a problem or not, okay? I think we continually reinforce that we're funding the progress of science, and science gets revealed by building on the shoulders of those who come before us. And I don't think people really expect, for example, cancer to be cured overnight, although several cancers now practically are, for all intents and purposes, a few of them. And the discoveries that are made, whether it's detecting gravitational waves or imaging a black hole, detecting the real origin of cosmic rays, these come as breakthroughs, and people are really surprised and delighted. So I'm not sure we have the promise or the problem of promising. I do think continual engagement with the public is just extremely important to explain how science is done, how you make hypotheses, how you test them, how you question them. But a lot of science is very self-correcting. If you make some grand announcement, I remember when I first joined the agency 6 years ago, and there was an announcement by 4 very prominent researchers from terrific institutions that they had detected the bipolarization from the microwave background, which was really basically detecting gravitational waves from the origin of the cosmos, the Big Bang. And boy, they were nailed immediately. Absolutely. The other scientists came down on them and said, no, what you're detecting is dust in the galaxy, and here's the demonstration of that from satellite information. So I think science can be very self-regulatory.
Hi, I think I'm going to speak from a UK and Ireland perspective, and it particularly comes from when I was a community pharmacist, where you would get a lot of people that would read more sensationalized newspapers who have the latest cure for cancer, the latest cure for Alzheimer's as a headline every week, and people would bring in those articles. And when you would read them, it would be an experimental drug in mice, but the way that they're written, it seems to people that they're going to be a cure, and they're going to be a cure that's available the next day. And I think that as scientists, we need to work with media and work with science journalists to make sure that the information is accurate and it's not sensationalized and it's reasonable, or else I think over time people will get fed up of hearing about the latest cure for something when it is just based on, the article is just on basic science, and we need to be very careful.
Yes, we must have gender balance, so there must be a microphone this side and one that side. Yeah, very briefly. I think maybe from the standpoint of governments, one of the most challenging tasks in relation to science and what science can do is always to try and balance between, say, in our cases, South Africa, what one would regard as a national interest. Our priorities is to tackle poverty, inequality, and unemployment, which sometimes clashes with what is seen as scientific or academic freedom by the researchers and scientists, versus, of course, the other issue of corporate interests that sometimes are embedded in what can be done and what should not be done. So from a government point of view, that usually is one of the biggest difficulties. Of course, sometimes government can act in a populist manner and promise things that are actually not going to be able to happen. Sometimes not even funding enough, the kind of research that is required. Like in the issue of cancer now. South Africa at the moment, cancer is really threatening to even overtake HIV and AIDS in terms of its spreading and the death and the difficulty in actually treating it. Sometimes government may tend to act in a populist way as if it's easy to solve that problem. So it's also balancing these various interests. And also the issue of ethics is located there in that attempt to try and balance the various interests.
My feeling is the interaction with society, I think, is very important, and awareness, scientific awareness, scientific understanding. I think society has to know supporting research is not always going to give positive results. They have to understand the risks, and they have to understand that this risk may cost money, but there are so many lessons that one can learn from the failure. And this is, I think, what, for example, the Gates Foundation, that has a huge project, they call it Grand Challenges in Global Health. So they put a lot of money and they provide grants, competitive grants, but they make it very clear to all those grantees that don't worry if you fail. You will try your best. They are selected competitively and on the basis of merit, but they tell them, don't worry about failure. You just go ahead and do it, because there are so many lessons that we can learn from the failure itself. And I think all these issues have to be explained to society somehow, so that society will know that I put a lot of money into this project and there is nothing that comes out of it. But they have to understand all these issues.
I think the question may be somewhat different between basic research and applied science. In case of applied science, we can assess relatively easy by the scientific analysis whether this project is worthwhile or not, and this can be successfully produce something effective for the society. It's easy to assess relatively, but basic research sometimes takes long time. In case of Blue LED, Akasaki Amano is my friend, they spent almost 40 years. In case of Noyori, he spent 30 years. And you remember lithium ionic battery, it also spent more than 30 years to complete. And at the start, no one can believe it is possible or it is important or not. And most of these people publish their paper at the start in a small journal rather than Nature Cell Science, very small journal. But later, citation increased quickly and become realized. But at start, no one knows, no one can expect whether they can succeed or not. Most of people cannot succeed. So from the side of funding agency, we need to support with a small money, long stand and wide variety of people. It's like cultivating people and get the strong seed from these research. That's the difference, I think.
Yes, I understand. It's totally different in discovery research and targeted research. I don't want to ask my other questions. I would like to ask the audience if anybody has a question. There are some microphones, so please here.
Speaking of ethics of science funding, I don't know if my question is ethical. Do you think the funding agency are 100% transparent when they announce the winning projects or proposals? Because sometimes we hear even if it's qualified, the proposal, the applicants, for the research proposal, and you pass evaluation step 1 and 2, but then we have to make, into consideration the regional distribution and gender and all of that. So I don't know, is this ethical? Is my question clear?
Can you so are you worried that funding agencies are not confessing
EU, for example, because we hear sometimes from the evaluation committees that, this passed all the TORs and the evaluation criteria, but then we meet and then we have to, consider the distribution of the regional. For example, the Middle East should take this and then. So I don't know if this is ethical, if it's true, of course.
Sure. Well, it's ethical as long as you say what your process is. So I think the program officers have a very hard time in all this. So 20% of the time they get to bring proposers good news. 80% of the proposals we get, we turn down, and that's bad news, okay? So nobody wants to hear that their proposals are turned down. So we have, in the States, we have a merit review report, which our board, the National Science Board, insists on, where we try to strive for that transparency that you're talking about that is a really important component of ethics. So is fairness. There's a lot of components of being ethical, right? And part of fairness, and at the direction of Congress, we've tried to fund all those areas of the country that do not get funded as high as some other areas. So we have a geographical consideration. We have a consideration for young investigators. So we have some programs where we say very transparently that this will favor emerging scholars or people who are within 10 years of their PhDs and so forth. I think as long as you lay it out there, and then there's another very important component, that it's not just done by scores. So yes, you can have the merit reviewers. We have sometimes 600 people a day, every day, come through from the outside to review proposals, okay? They're all in little rooms, they're all talking and very intensely, they're rating, they're ranking, they're discussing, they're re-rating and ranking. But then it's up to the program officers, and this is where it's so important that you hire good people, and we hire them from all the universities. They come in for 2 to 4 years to help us out with that process. And they have to balance, and I think that's what you're really talking about. How do you balance all these considerations of funding women, funding areas in the country that are not so well funded, funding people across the age spectrum, funding ethnicities and all that. And they have to come out with a balanced program. If the 10 highest proposals all look identical, you don't want to do that either, because it's not opening up the whole line of discovery research. So there's just a lot of considerations in there. I think what you're really asking is, do we explain that process, and that it's more complicated than just giving a number to 50,000 proposals that come in every year. And we do try to do that. Yeah.
Thank you. So next question, please.
Yes, thank you very much. Well, I'd like to address my question to also Mrs. Cordova. I'm sorry to bother you with all these questions, but you see, we in Jordan, we've tried for many years to collaborate with the National Science Foundation, and at the time of, if you remember, Mr. Shnation, he came to Jordan and we signed a memorandum of understanding to collaborate with National Science Foundation. But we faced one problem really by doing this. The simple fact that you have a certain prerequisite for eligibility of funding through the National Science Foundation, and that is that the principal investigator should be an American.
Yes.
You see? But aren't you afraid, this is my question, that you would miss on good and important and viable ideas by doing this, that you don't get any, let's say, input from the outside world? Why don't the EU have that? The EU and their different framework programs, their current Horizon 2020, the upcoming Horizon Europe, they don't have such a prerequisite. So can you explain why?
Yeah, in fact,
with this? Thank you.
Absolutely. So I had a nice lunch talk with Jean-Pierre Bourguignon of the European Research Council and Commission today about his program to welcome everybody from around the world to propose, and they would fund them. And he said that out of 30 proposals, 8 are from the US, so they are funding people from the US. We do not have reciprocity in that. We are mandated by Congress, and this is, and there are agencies like USAID and others who have different mandates, and they do fund internationals, but we in the US, the National Science Foundation is mandated to only fund. We can fund international collaborations for sure, and we do lots and lots of that, and we publish reports on all the statistics. But the other countries have to fund their investigators, and we fund ours. So we have thousands of collaborations. In Africa alone, we have almost 500 collaborations. In many individual countries, we have many hundreds or thousands of collaborations. But we only can fund the U.S. portion. The argument is that our taxpayers are funding those proposals, and so the money should go to U.S. investigators. But that's the mandate that we're under. So we welcome international collaborations, but every country has to pay their own way. No, that's just the rules.
Okay. Next question, please.
My name is Martin Dominic. I'm at the University of St Andrews in Scotland. I would like to get back to research integrity. I much appreciate all the various efforts undertaken on this. But if rigor and integrity do not take priority over outputs and impact, we fail on trust and credibility. How do we make it a priority rather than just giving it consideration?
Okay, who wants to answer that question?
So I don't know if I'm really answering it, but I'll just give my comments. So I think that, do you remember the papers a couple of years ago with the scientists that were dipping the stem cells in acid and then or fibroblasts and then producing stem cells? I think that just epitomizes the competition that we're under to publish in really high impact journals and how it's destroying, to a certain extent, the integrity of research, and that we need to learn from these examples and learn from impact factor isn't necessarily the best research.
Okay, thank you very much. I don't see any. Okay, the last question. Gentleman there.
Oh, can you see me? I'm really tiny.
Cannot hear you.
Okay, so my question is about the ethical research. How can young independent research who are not associated with a higher education or a research center certify ethical research process?
So the question is about, if I understand correctly, about funding independent research which is not coupled to any institution.
Maybe I could attempt to respond to that by illustrating about what we intend to do in South Africa. We've taken a very important policy decision of establishing a sovereign innovation fund whose aim we are discussing now, but primarily to incentivize and support research, crowd in research, say from the private sector and so on. But maybe the advantage of a sovereign innovation fund is that it will also fund where other researchers or research funds may not be willing to actually fund. But if it's something that is important, we may not, for instance, bring about like basic research, aspects of basic research. Because now there is this shift and pressure towards patents, towards innovation and so on, and abandonment of basic research as another consideration, as well as areas. For instance, in South Africa, we are trying to put more money into indigenous knowledge systems, and also to, by the way, even put funding to support patenting from where that innovation arises, because in the African continent, we've had a problem, you know, that most of the research that has come out and innovations are patented outside of the African continent, you know, somewhere else. So from the point of view of what we are saying and the question that we are asking, a balance is needed, and how best to do that, I was just trying to make an example with what we are trying to do in South Africa.
Okay, can you pass the microphone? Stephanie, can you pass the microphone? So, Director Cordova wants to comment on one thing.
Yeah, so you're about to close the session, which is great. So Stephanie said something earlier, and I just thought that I really need to just to comment on your comment, that because it's very important to me and everybody who heads a research agency that young people like you're the young person on this panel, you're the emerging scholar, that they have every opportunity to propose for the thing that they think is the most important. And your comment suggested, maybe I didn't interpret it correctly, that you thought that maybe the agencies were getting too far along with defining their areas that are their strategic areas, and that could produce the bias against having the most creativity from people like you that thought that the universe needs to be explored in a completely different way. And I just want to assure you that when all the Global Research Council people get together from the funding agencies all over the world, that is what we talk about. We all are absolutely committed to curiosity-driven research that at its heart doesn't even know where it's going to go with respect to outcomes. And we want your ideas. We want the best ideas of the emerging generation. That said, of course, we're going to have strategic areas of emphasis. We need them from our funders. Congress, for example, in our case, expects it. The administration expects it. It's a good framework to have. It encourages the public to think that there are lines of research that need to be pursued. But the biggest breakthroughs have never come from incremental research. They've come from wholly new disruptive ideas that come out of a generation like yours. So keep applying, because there is definitely room from the funder's point of view.
Well, Director Cordova, thank you very much for your closing remarks. We are a little bit late, 10 minutes actually. I would like to thank all our speakers, and now we will have 20 minutes break. Thank you again.